In this video, we'll introduce how to create a simple plot in Python using the Numpy and Matplotlib packages. Now I should note that I'm using the Jupyter Notebook interface. However, if you prefer to use a pure Python script, you can do that by putting the commands in a text editor, saving it as .py, and running it natively through Python. Unlike other software packages such as MATLAB, Python natively doesn't have many linear algebra commands or plotting functions. So we need to specifically import outside packages that will allow us to run these commands. So we do this using the import function. And the first package we're going to use is Numpy, or numerical Python. Now, when we want to call a function from Numpy, we need to tell Python that it belongs to Numpy. And that would be, for example, if we wanted to have, a range of values, we would say numpy.arange, telling us to use the arange function that belongs to Numpy. Because that will get tedious after a while consistently writing Numpy, we're going to import Numpy as an abbreviation NP. The same thing we're going to do with the plotting functions which belong to Matplotlib. So we're going to say import matplotlib.pyplot as PLT. And if we want our plots to show up within the Jupyter Notebook interface, we're going to say $% matplotlib inline. Now to run a cell within the Jupyter Notebook, we do that by pressing Shift-Enter. When the cell is running, we see that there is a star, and once it's completed, within the brackets over on this side, you'll see a line number. Okay, so now that we imported all of the required packages, let's start by creating sets of variables that we're going to use to plot. Now, the first thing following good programming practice is to inform the person who's going to be reading your code what this code does. So we accomplish this by using a comment, which is shown by the # within Python. Now, anything following a # will not be read by the computer. It's only for you or the reader to read. So in this case, let's call this a simple plot using Matplotlib and Numpy. Okay, so the first thing we're going to want to do is to define a set of variables. Now, some of the variables we want to define are maybe the independent variable that we'll call xgrid, the dependent variable y, which in this case will be the function y is equal to x squared, and then other variables which will pertain to the figure we're going to create. So there are several ways to discretize a system, and if you don't remember how, I would recommend reviewing one of my previous videos on the basics of scientific computing. But we begin by specifying the minimum value we want our independent variable to take, which I'm going to call xmin, and let's say that this is going to be -2. We want to specify the maximum value, which we'll call xmax, which is equal to 2, and the spacing between each point. And let's call this 0.1. Now, for those who may have some past experience with other programming languages, such as MATLAB or maybe Julia, you'd probably follow each variable declaration with a semicolon, telling it not to output the variable to the screen. Python does not automatically output variables to the screen, and instead we'd want to use the print function and explicitly tell it. So we should remember that unless we really want something to be printed to the screen, we don't need to really do anything. Okay, so now we have the basis of our grid. We have the starting point, we have the ending point, and the grid spacing. Now what we want to do is come up with a grid that will correspond to the individual values of our independent variable. To do this, we can use the command arange. So we're going to call our grid xgrid, and aRange belongs to Numpy, so we're going to say np.arange. Now, what this is going to do is this is going to create a range of values starting at the first value and ending at the last value, but not including the last value. This is because Python starts with 0 as a counter and not 1. So if we want to go up all the way to 2 within our set of numbers, we're going to have to say xmax plus dx. So again, we can read this as a command telling the computer, okay, I want a range of values that start at the minimum value, -2, goes up to, and because we want to include the last value of 2, we're going to say plus dx in increments of dx. Now if I hit Shift Enter, it'll run the commands. Now let's say if I wanted to take a look at what xgrid looked like. I could use the print function, which will display a variable, xgrid, and click Shift Enter, and we see that we have an array of values that starts with -2, goes up by 0.1, and ends at 2. Now the next thing we want to do is we want to specify our dependent variable. Now I'm going to get rid of this because it really doesn't help us to see all of these values. So I can delete it and rerun the cell by pressing Shift Enter, and we'll get rid of the contents. Now, one thing we should say with Python or Jupyter Notebooks, it does continue to store these variables. So it's possible if you're doing a high number of computations and you do Shift Enter, and delete, those values are still stored, and you'll want to actually restart the kernel, which I'll talk about at a later video. So now that we have our xgrid, it's really quite simple to come up with our dependent variable. So let's say define our dependent variable as y is equal to x squared. Now again, from those people that are coming from MATLAB, in MATLAB you have to specifically tell MATLAB that you want to do an element by element operation, because natively it'll assume that you want to do some kind of matrix multiplication. However, Python is not the case. We would have to specify if we wanted to say do a matrix multiplication, but its default is to take all the elements within an array and to perform an operation. So we can just say y is equal to x squared. Now exponentiation within Python is done by the 2 stars or the 2 asterisks and not the caret up top. Okay, if we want to press Shift Enter, again, we see that this should have run, but what did I do wrong? Well, it's within our declaration of variables. When we're programming, we need to make sure that we always define our variables and carry them consistently throughout the entire program, because the computer can't infer what you're thinking. So right now we say, okay, there's an error. The computer says, I don't know what x is, because we haven't defined it. So what we want to do is we want to actually change this to say y is equal to x grid. And again, by pressing Shift Enter, we can run that command. Now, we want to plot the data. What we're going to do is we're going to create a figure object. Within that figure object, we'll create a set of axes that will be used to plot, and then we'll alter that object by adding titles and limits and other things like that. Now, if the word object is foreign to you, don't worry about it. Just think of it as a thing that we're going to be adding to. So for example, you can think of the figure object as a piece of paper that we're going to want to do something to. We're going to want to draw some axes and then draw a plot. We'll talk about object-oriented programming and its benefits in later videos, but right now, just think of it as that piece of paper, okay? So we want to specify that we're going to be using a figure. So we can again define a variable, fig, that is equal to plt dot figure. This is going to create a figure, and again, if we shift run it, we see the output is a figure entitled matplotlib.figure.figure. Now there's nothing there because we haven't added anything to it. Okay, so we're going to take that fig variable and we're going to use it, and we're going to create a new variable that's going to be the axes of our plot. So we can call them ax is equal to fig dot, and now we're using this dot operator again. We've seen that before when we used np.arange. So this is telling us that we're going to be using or something having to do with this figure. Just like how up here we were saying, okay, we want to use the Numpy package to get arange, and now we're going to want to use something within this figure to allow us to create axis. So if I do add and then shift, we can start seeing, all the different things we can do with this figure object. Now what we want to do is we want to add subplot. And we're going to use 1, 1, 1. Now right now I'm not going to go in depth about these 1, 1, 1s mean. Basically it's a way of adding multiple plots to a single figure. And what we're saying now is essentially we just want one figure. Okay? If we shift enter and run it, aha, we have our plot. Now, let's think about this logically. Okay, we have our figure. We added axes to it. Now what do we want to add to our axes? We want to add our plot. So we're going to be using the axis variable, ax, and we're going to plot. What are we going to plot? We're going to plot our values for our independent variable and our dependent variable, which is y. And if we do shift enter, we have our parabola. Now, we're not done yet because a good figure should have several things. It should have properly scaled axes, which we have here, but I'll show you how to create, say, if we wanted to go out from -5 to 5 on our window. It should have a title, and it should have axis labels. All of which we can add by using this ax figure. So we can say ax.set x label. Now this is going to be a method of my axis object that we can add something to it. What do we want to add to? We want to add a set of words or strings or X, right? Some kind of label. So this is going to take in a string as an argument, and whatever that string is, it's going to display right here on the bottom. So let's say X. And if we do shift enter, there we go. We see that X is automatically displayed. Next we want to add a Y label, which we're going to define as Y. And we can add in a title, and let's call this a simple plot. And here we go. Now we see that we're pretty much done, but sometimes we're going to want to see a larger span of our window. So we can set the axis labels, or the axis endpoints, by using ax.set xlim, and let's say we want to go from -5 to 5. And here we go. We see that our axes extend to -5 to 5. And let's say we want our y to go to set ylim from 0 to 5. And here we go. So here's a graph of our parabola with properly formatted axes. Now, if we wanted to save this figure, we could say plt, again, using a function from the plt package, save fig, and let's say this as simple plot.png. And this will save the figure to whatever directory you're working in. So if I do Shift Enter, voila, I have my simple plot made in Python. So let's just quickly recap what we learned. We learned how to define a simple array of gridded values and perform operations on that grid. And then we discussed how we can come up with a plot in Python using the fig, ax, and other specific commands pertinent to plotting. And let's just recap what that logic was. That logic was first to create a figure object, i.e. a blank piece of paper. The next thing is to create a set of axes on that object, shown here by the x and y axes, that will do something to, in this case, plot. We'll then tell it to plot our independent and dependent variables. And then we can set our values for the x-lim and the y-lim, i.e. the limits of our window. We can set a title, we can set axis labels, and finally we can save the plot using the plt.savefig command. Now, say if I didn't press Shift Enter throughout all of these, and I'm just going down and typing all of my commands without doing Shift Enter, moving from cell to cell, or if I had it on a single cell, we could go to the kernel option and then say restart and run all. It'll give you a little warning box, and then if I do restart and run all, it'll restart. Might take a minute depending on the computer that you're using. And voila, you'll have a plot in Python. Now, for those who are not using the Jupyter Notebook, you can copy and paste these commands into a simple text editor, go into the terminal, do Python and the name of that Py file, and run it, and it will also save your figure to a given directory. Thank you for watching, and I look forward to seeing you again in future videos on scientific computing.